Hey Vaibhav. So yeah, are you able to hear me, everyone? Great. All right. So yesterday we discussed the design, the data model, and how do you generally design your database architecture, in Hadoop and HBase actually. Okay. So are there any questions on this? Did you get a clear picture of what's going on? All right. So again, in a table, the indexing is based on row. So these are the things you have to keep in mind when designing the your data model. Okay, meaning tables are sorted based on the row key. Each region of the table has sorted key space, start key and end key. So because as we discussed earlier, table is broken into regions, and each region is denoted by start and end key because the region is sorted by the region is sorted by the row key. Therefore, it's okay to denote the region by start key and end key. Everything in HBase table is stored in byte array. There is no data type like integer, string, or anything. Okay, the values as well as the column name and row key all are byte arrays. Okay, so there are few drivers which make it possible to make HBase look like a normal database, right? So they try to show that there is a integer data type, there is this data type, and all that. Okay, but under the hood, HBase does not have a concept of data types. Everything is a byte array. Atomicity is guaranteed only at row level. Okay, there is no multi-row transactions. Column families have to be declared and defined upfront while creating the table. Okay, it's difficult to modify the column families. In column families, we just mention the column names, that's all. So while creating a table, all we require is the name of the column families, that's all. Okay, column qualifier, as in the name of the columns, can be anything. We can keep on adding more and more columns as and when they want. The way the table expands vertically, as in we add more rows, in the same fashion we also keep on adding the columns. Okay, so this cycle takes a lot of time to change because in RDBMS we did not expect the table to expand horizontally as in number of columns increasing, but we always did a vertical addition of the rows, right? But in this case, you can always think of a table like a matrix which has x and y and it can expand on both the dimensions. Okay? And whenever you do an operation, the data is ordered in the following manner. First, it's ordered by row key, then column family name, and then column qualifier. and then timestamp etc. Column qualifier as in name of the column. Okay, so a little hands-on. Let's have a look at what's the situation. Do you have any questions related to the data model of HBase? All right. So here you can see, I think it's up now. All right. You can do HBase shell. All right. We can check the status by typing the status command. It says that all three region servers are dead. Probably nobody was using them. And ouch. Wow. Wow. The HBase is really, really busy. So Matthew, try using Pig at Hadoop 2 or 3. Okay. Hadoop 1 is generally a little more packed. Yeah, login is same. All right, I think let it stabilize, and then we can discuss it again. All right, let it stabilize. It's trying to do things. Okay, let this name node start, and then we can discuss again. All right. So we'll just go through these commands. So hbase shell is the command prompt. Uh, After this, you can check the status of hbase, and you can create a table. This is a table name, and you can add as many column families as you want. Okay, by putting a comma in it. Then to check the list of tables, you can simply type list, or you can put a regular expression along with it, and then you can put the values in the call table. Say this is my table, this is my row, and this is my row ID, and this is my column name. Column name is column family, colon the name of the column. Okay, so the column qualifier is col1. So if you combine the column family name with the, just a second. All right, so you see the column family name and the column name and then the value. Then you can scan the table as in do a select star. And if you want a specific value, you can say get my table, then the row ID, and also mention the column name. You can check the table description by doing describe. And to delete a table, you have to do the two steps. First disable, then drop. All right. Wow, everything is stuck. All right. And yeah, the name node is not working. It will not be possible to do anything. Yeah. If name node is not working, then we can't access the file browser. So which process should I kill? This one looks. All right. So I'm trying to see why it's not coming up. All right, memory is really high. All right. All right, I'm just restarting this server number one and then check what's wrong. All right, we have a question from Vaibhav. All right, let me. So even as we add column family and column over the life of table, HBase will be storing them in sorted order. Yes. So do you mean that the column name will be sorted in the sorted order? Just okay. Okay, so which one? All right. So first, we cannot add column families over the life of a table. Okay. So I'm assuming that you are trying to say that if we add more columns over the tables, HBase will be sorting them in sorted order. Yes, columns will be in the sorted order. So no matter how many columns are you keep on adding, they will be in the sorted order. Yes, that's correct, Rebel. All right. So I'm just hoping that this thing should work. All right, let that start, and once that gets started, we'll have to log in. All right. So not working. All right. So I've restarted the host. So I'm restarting all the services on it, and we'll wait a little bit to get them up and running. All right. Okay. Till that comes up, let's finish couple of concepts. So the locking is per row, as in, as we have already discussed, that in a transaction, the whole row level transaction is considered. You cannot have like multiple rows or multiple table kind of in a transaction. All right. All right. So if you are inclined towards Java, then you can use the some a concept called scanner to scan the table. So scanners are like your cursor. The way you have cursor, you give some conditions, get the result, and then you keep on getting next cursors. Okay, next window of the cursor. So in the same manner, you have cursors in HBase also, that you you open a cursor on on a database, but to open a cursor you define the scan area. The scan area is basically to select which region to display. Okay, which region to display, and first parameter you give in scan is that where is which what is the starting row, and what is the row at which you have to stop, and name of the columns which you need to return. It's equivalent of saying select a comma b from a table where row id is from here to there. Okay, and sometimes you want to run a filter on the server side so that only those rows are selected which qualify a certain filter. Okay, this reduces the load of data transfer from server to you. Okay, and once you are done with reading from, let's say when you opened a scanner, there are millions of rows that have resulted in that. Okay, so you will only get the window over one region at a time. Once you have finished processing the result from one region, you can say next, and then there will be a trip back to the server to get the result. Okay, so that's how it works. So whatever table creation we have demonstrated, the same could be done using Java. Although the code looks really complex, but it is not. It is actually extremely simple. Just because in Java you have to type things twice. That's why, like, configuration on the left hand side, configuration on the right hand side. Similarly here. That's why it looks too verbose. So all we are trying to do is first create an instance of config HBase configuration. So this config object contains all the details about which server to connect and all the information. Next is creating a admin handler from the config. So this admin handler will be responsible for creating table, adding columns in a column family, or defining a column family. Okay, so we have HBase admin, okay, which is created on top of config. You can see that we are passing config object here, and then we are creating table description. So we first created test, which is the name of the table. Then we created a column family called data. And then we added this column family to this table description. And after we have done all of this, we create this table. So it's like first we defined table name, then column family here, this one, and then we added this column family to the table, and that's all. And once that is done, we are adding this column family, I mean table, to the config, to the admin. Okay, which means we are asking admin to create this particular table. Afterwards, we can go ahead and check whether it has been created or not. So this admin handle gives us the further commands like list tables. It'll give you the list of tables, and after that you can iterate over the list of table and check whether this table which we have created, we can check it quickly. All right. So Kiran's question is, don't we have any HBase editor developer where we can create view table or insert, update, delete data? So for HBase, I don't think so. For HBase, I don't think so because let's just see Uzi reason. All right, just a second. And yeah, okay. Now everything seems to be up except for the reason servers. They are also coming up. Um, just checking if our file browser is working. Yeah, now it's working. All right. So we were talking about, yeah. So there is not right now. There is no available editor in Hue. I think the newer versions of Hue will include the HBase editor. Okay. Right now it doesn't have any. Okay, but from the programming perspective, from the way of accessing HBase, there are few APIs, the interfaces, the web interface and all, but there is no like how should I say, a studio kind of environment to edit the HBase. All right, that was Kiran's question. Matthew's question is, do we have to write all that code every time we make table? If you are doing it through Java client, but if you are doing through the shell, it's very straightforward. Okay, it's very straightforward. So let me just check if the reason servers have come up. Yeah, now reason servers have come up. All right, let me try to show you that how to create a table. So you can simply create a table like this. You can say this is my column family 1 and this is my column family, say 2. Okay, So yeah, HBase developer or admin will create the table from the shell or from the API. So you can see that right now if you do scan my table, so there are no rows in and no columns in this. Also you can have a look at the list of tables. There are quite a few tables, and you can further pick a table and check what is inside it. Okay, you can say describe, so it tells you all the details about HBase. Okay, this particular table, it has got these many, this is the column family it has got, and there is a bloom filter enabled on row and so on. All right, next is you can put the data in the table based on this. Okay, so you can, since, okay, so you can put into my table which we just created row 1. Let's say we have two column families right now, so we are putting data into one column families, one column with this, and let's say in the same column family we are adding another column, and let's say we are adding at the same time. What I wanted to demonstrate is we can add one more column here and add some value. Similarly, in the same row, in the same column, if you have different row, let's say 2, okay, here you can put data in the string format. Okay, let me again explain what exactly I'm trying to do. So we have just created a table called my table, which has got two column family, mycf2 and mycf1. In same column family, same column, you can put two data types. This is string, this is number. Okay, so let me try to show you. Okay, now you can see scan my table, right? See two rows, row 1 and row 2. Now you can keep on adding more and more columns in a column family. Okay, so we have added three columns into column family. Scan my table. Scan my table. Now you can see that. You can see row 1 contains one column, two column, three column. Row 2 contains only one column. Make sense to all of you? Alright. If you want to get a specific value for a table, for a particular cell, you can get it. Alright. So we can say my table row and my CF1, not my CF. Okay. So it gives you the value along with the timestamp. All right. Now, if you want to see the status of your table, there is a little bit of UI as Kiran was asking. Here you can go through the UI like this, okay, where you have these list of tables. That's the only UI we have right now, but there are people who are working on this. All right, and so these are the tables. The table which we were handling, this is the table which we were talking about. Okay, all right. There is a one more concept which I have not included in the slides. So sometimes what happens is that in a particular row range, okay, row range in a particular row range, there is too much traffic. So row range as in, let's say there are 1,000 rows, okay, and 1 to 5th row is in region 1, and 5 to, or let's say 1 to 50 is here, 50 to 100 is on region 2, and so on. Okay, now, or where is our diagram? Yeah, let's imagine that there is this huge number of rows which has got many regions, but for some reason we realize that the number of requests are too high for a particular range. Let's say there are lots of requests are coming for a particular key range. Okay, let's say T to Z. Lots of people are querying for the keys which are starting from T till Z. Now this particular region server will be swamped, right? And the load is not distributed. Okay, if there is a demand of certain region really high, then you will be in trouble. Correct? This particular phenomena is called hot spotting. This this particular problem is called hot spotting, or you can say your H-based region server hotspotting, meaning one particular region has become a big hotspot. Everybody is accessing it for some reason. Okay. Now, in those cases, what you can do to avoid the hotspot is go here and split a particular region. Okay. Right now, there is only one region. That's why it's showing you split here. You can also split on a particular key. That means you're forcing HBase to split the region by your choice rather than based on the size. That way you can solve the problem of hotspotting, or you can keep on splitting it at least 4 or 5 times. Then you will have multiple regions. All right. So that is one thing which I wanted to discuss other than these slides. So coming back here, you can have a look at what are the tables available in HBase and all. Alright. Next is, now next question which we did not answer is, where is my data? Okay, where exactly is my data? So your data is generally in this folder. So HBase under the hood is storing your data in HDFS, and that is in this folder called apps HBase data, and under that data. Okay, if you go into default, you will see all these tables. And what was the name of our table? My table. Okay, under this my table, as we're describing here, you can see, so under this database will be your table name, that was my table here, and then will be reason right now, and this reason name is automatically generated, and after the reason name there will be column family, and then there will be a store file. Now you can see that for each file there are store files. Okay, for each column family there are store files, which means the data of each column family is staying together. All right. Now coming back here. No, this one. Yeah. So you can see that there is my table. Under that, there is a reason. If there are multiple reasons, if we are adding more and more data into this table, it will split into multiple reasons. Okay. Right now, there is two column family. So for each column family, there is a column separate folder. Okay. So in my column family, my CF1, where is the data? Maybe it's waiting for the flush. Or did we delete the table? Scan my table. Scan my table. There are row 1 and column family 1. I think it's still in the, yeah, this is 22 August. Alright, the data would be here, just that we need to maybe refresh or something. Alright, I'm just wondering, as in, so in this folder there is a data, it just has maybe created some sort of temporary file somewhere, maybe waiting for more data to get added. So if we try to put more data, let's try to put more data into this. All right, I'll come back to your questions in a minute. Yeah, this is where it actually keeps all the data. If you have a look at other tables, all right, here also there are two column families, so it keeps the data in this file. So this is the file containing the column families data. All right, so now you can visualize it this way. I'll try to show you. So Kiran's question is, there are a few more questions. Let me. Oh, actually, it's still lying in the temporary data. Somewhere it's lying in the temporary data. All right, it should flash. Flush my table. Now it has come. Yeah, it was waiting for flush. Okay. Still, the second one is not even flushed. All right, never mind. So scan my table, and it should show you. So, oh, we have not added anything into the column family 2. That is the reason. Okay, if we add something into column family 2, then it will be. So, so this folder structure is clear to you, that we had this table, and again flush is required. So we had this table called my table. We created rows in it. So by default, everything is in a single region, meaning there is a single folder that will contain the data. And as and when we'll create more and more data, if we'll push more and more data, there'll be more folders that will be created here. And under that folder, there are two column families. Okay, for each column family, the data is in a single place. Now, why I'm talking about this is to let you understand the data locality concept. So, the way it looks like is okay. So, let's say there was a big table like this. Okay, it has some certain rows, like this is my first row, this is the first row, this is the second row, and this is the third row, and this is the fourth row. Okay, so first the table will be splitted into the regions. So this is one region. Okay, and let's say this is another region. Okay, region number one, region number two. Also, what you can do is you can change the colors. There are two regions like this. Okay, now if the table has got multiple families, let's say there are two families, and under each family there are certain section of data. Okay, so it will be divided like this. So effectively there are four sections. Effectively at the end of day there will be four files in HDFS like this. Okay, now back to your questions. Weber's question is, when a row needs to be inserted via cell, do I know do I need to know the row number to be added? Yes. So you have to insert the row ID always. Okay? It's like key value pair. So key has to be there, and it will be done by you. Now Kiran's question is, do we have a sequence generator in HBase? Creating unique row IDs every time is a pain, as we can have to scan again all the row IDs to avoid duplicate row IDs. That's okay. So generally row ID row ID is something you utilize. So before you start working, you think about your data structure. So there cannot be any table structure in which there is no index you want to create. Okay, if you want to, because in every table there will be some kind of a usage pattern. So generally you can use any of the row ID if you have. Otherwise, every programming language provides a random number generator. You can use that one. Okay, and you don't have to scan it. All you have to yeah, generate a random number, check if it already exists or not. If it already exists, generate again. Okay. So there are user ID generators like UUID in case of Java. It generates the random number for you. Similar is with Python and other languages. All right. Vaibhav and Kiran, did I make sense? All right. Great. Moving on. So we demonstrated to you how is the data is stored, and probably that will also help you understand that your table is splitted across multiple files across the cluster. So you have to take care of things what you need to define. So you have to take care of few things like which column should go in which column family, because if you frequently try to query some columns from this side, some columns from this side, and some columns from this side, then you are essentially accessing two files. Okay. And if you are trying to scan through the database, then you might end up scanning these also. Right? So four file for a small query will become a little big headache when it comes to accessing the data. All right. So that's how it is. Those who are interested in further like who want to run mapper and reducer, so the way when we were creating our map reduce, our all of the structure was against a file system. So we defined that this is my input file, this is my input data, and on that data we run our mapper, and resulting output of mapper after being sorted by Hadoop goes to your reducer. Almost everything is true in case of MapReduce over HBase, just that instead of a table, now you have instead of a file which was input to your MapReduce in the classic sense, instead of a big file as input, now you have a table as input. And instead of a line in the table, like when we did word count, one line was an input to our map function. Here is one row which is an input to our map function. So when you are creating map reduce for HBase, so you create a mapper that extends the table mapper, and you define the data type just the way you defined earlier. Instead of saying only mapper, you say table mapper. And once that is done, you can basically here create a method called map, to which you can see that the row has been given to you. The full row as input is given to you, and there is no key value. There is only one row which is given to you. And on top of that, you can, after doing all the processing, you can push the result into context. Okay. So right now, all we are doing is we are going through the rows and emitting the values here. All right. Similarly, we can create our reducer which extends table reducer, and we have key and the value. All right. And key and the value which is coming to you is in the form of key is normal text, and value is a iterator, as in there is a list of values. Now your reducer can take these values and create the summary. Okay, and once you are done with creating summary, you can push the results to the context. So that's how you, and once you are done with that, you can create your map reduce stitch, as in you can stitch it just the way you had driver. In the same fashion, you can create any Java code containing this information. First you create a config object, then you define a job, and then you define a scan region. That's an optional thing. And you define your mapper job. Okay, so in the mapper job you can optionally mark that this is my scan area. Instead of running your map reducer on the whole table, you can run on a small section. Okay, so you can say that run my mapper reducer only on the first part, this part. Okay, by specifying the starting row, end row, and all that. All right, you can similarly define a reduce job and also define number of reducers. So basically we are running reducer on top of each row, because this has how many rows? One, two, three, four, five, six. So six rows. Full rows data will be available to your mapper function, where it can take the action, whatever it wants to do. Kiran's question is, all right. Kiran's question is, but if we are creating millions of rows, then how effectively can we create unique row IDs? All right. So it's an important thing to note that when you are creating millions of rows, generally you have some row identifier, because earlier in case of databases, you did not intend to create a row identifier. Why? First, because there was no need to do so, because you could index it later point of time. But here, that's the only hope you have with respect to indexing. All right, if you have if you figure out that this is your identifier, this particular value is your identifier, and there are chances that these might be duplicate, so you can make an arrangement such that all those row values having the row id merged into a single row, and hence your row id will remain as such. So all I'm trying to say is, generally in case of hbase, people have their definition of row id very clear. Okay, and when you also design it, you will realize that it is makes more sense to always have a row id. Okay, and for a table, first, tables are not very small, unlike our databases, where tables like mapping between one table and another table did not require any unique id. Similarly, we did not need index on it sometimes. But here there is no concept of indexes. The only way you can have indexes across the rows is using row id. So there are high chances that you will have you will not need to worry about auto generating the row id. But still, if even if you have, then random number generator is okay. Random is not that bad a design. Okay, you can simply say hbase dot get this, and it will quickly check whether that particular key exists or not. If it doesn't exist, then you can create it. Okay, also, all right, and so basically hbase has not provided a row id generator, and if they have, I might have to check. Okay, just like in case of mongodb, mongodb provides you a way of creating the row id automatically. Okay, but hbase doesn't seem to provide you a library inherently. All right, next question from Karan is, how can we handle rollbacks? Okay, so rollbacks are basically whenever we are inserting data and we have inserted only partial data, you want to roll back. But let's say your insert is resulting in multiple rows across multiple table. Correct? That's your question. So let's say whenever you are inserting the data and it's resulting in multiple row insertions, modifications, and all that. Okay, so in all these circumstances, it's difficult to get the multiple table or multiple row editing done through HBase. What you can do is the way we call it two-phase commit. So we can artificially create a two-phase commit, as in, let's say there is a row. So let me try to explain what am I trying to show. Okay, so um, what we can do is we can have a separate table containing the transaction status. Okay, okay, where each row in this table contains all information regarding regarding the full transaction. Okay, now since there is a row level transaction in HBase, so based on this row you can actually create the full table kind of a transaction. Okay, meaning you have this row which has marked that these are the things to be done, and it has maybe three statuses: status 1, status 2, status 3. Now you can use this row for having a transaction. Okay, so and you can actually do a two-phase commits here. You can have the rollback also just using this particular row. Did not make sense to you? I hope I could. Let's say in this row you mark it. There are three column: status 1, status 2, and status 3. Okay, and when you are updating this row, you can update these statuses, saying that this has failed, or this is successful. Okay, and this has failed, or this is also, let's say, successful. Now if so basically we'll maintain the whole transaction in a in a single row, the state of the transaction in a single row, because row wise transaction is possible. Therefore, in case something has failed, then we manually go back and delete it. Delete these two. Okay. If something has failed, we go back manually and delete these two. The records which have been created part of this. Okay. So you have to artificially create these transaction status, and maybe there is some H-based library which does it for you. Okay. But you can create these kind of two-phase commits. All right. Yeah. So Kiran's question is not still clear. I don't have a pre-prepared example, but I can give you a good starting point. All right. So, all right. This would give you an idea how can you emulate the transactions. Okay. This should give you an idea as in how can you emulate the transaction from single row. This is a MongoDB documentation similar to HBase. In MongoDB also you have the transaction only on one row. In case of MongoDB, one row is equal to a document. Okay. One row is equal to a document. One row in a table is equivalent to a one document in MongoDB. Okay, that should give you a clear picture on what exactly I'm talking about. So you basically maintain a table. You maintain a table called accounts. Okay, you maintain a table called accounts, and it has got row ID as A, B, and these are the other columns. Balance equals to 1000. You also maintain another table called transactions. Under this table called transaction, there is an ID and you have source and destination. Okay. So, so whenever you are doing transactions, you mention that in a single document and make sure that is committed or not. So in the exact same fashion, you can emulate the transactions in HBase also. All right. So that should give you a good idea on how do you emulate the transaction using a single row commit. All right, good, good. Okay, so that was our MapReduce. How do you stage the MapReduce? Next is the Bloom filters. So this Bloom filter concept is very important. So although you don't have to implement Bloom filter by yourself, as I showed you that when you scan a table, when you scan not scan describe my table, Bloom filter is by default enabled, so you don't have to worry about enabling or disabling Bloom filter. Okay, why am I discussing this? Because because lots of people tend to ask this question, and it's a very important concept in the world of searching and technology. Okay. So, what exactly is a Bloom filter? Bloom filter is kind of an strategy. A Bloom filter is kind of a algorithm or strategy such that our searching becomes faster. Such that our searching becomes faster. Imagine this. There was there was a A, watchman 1, and he had say 100 registers. So whenever a person comes in, he has to scan through the all registers and find about this person, this visitor, whether it exists in the register or not. Now after a point of time, this watchman 1 got overloaded. So every time a person comes in, he goes through the register, uh, finding details about this person, and it takes a lot of time. When you have billions of record, even the binary search might take a lot of time, because accessing the actual record will take a lot of time, right? So that's where the concept of okay, so this watchman got tired of I mean, is overloaded all the time, because he has to go through all the registers. There are 100 registers. Even though the records are in each register, the records are sorted, still he is overloaded. So what he suggested was, let's have another watchman, okay, watchman 2 or watchman 0, okay, who will do quick and dirty check. Okay, so watchman 0 will be able to successfully check whether this person, so he can say confidently confidently says that a particular visitor is not in list, okay, not in our registers, but cannot cannot say confidently that he is in the register. Okay, so these two sentences are a little difficult to comprehend in first, but you will see that it's quite straightforward. So watchman one, who was overloaded because he has to go through hundreds of registers to check whether a visitor is allowed or not. So we came up with an idea of having one more watchman who does the quick and dirty check. And this watchman can confidently say that this person is not in the list, okay, but cannot confidently say that he is in the list. Okay, let's imagine how can this be done. Let's say we take the first two alphabets of each name. So we took all the registers and we picked up only the first two characters of each name. And then and then we just gave that small list of two letter words to watchman 0. Okay, now watchman 0 only goes through that small list, because how big could this list be? It could be 26 into 26, right? Which is 576. So is it 576? No, it is 6 something. 26 into 26, 676. Okay, 676. So, so basically, no matter how big are the registers, Watchman 0 will have only 676 entries, right? So whenever a user is coming, whenever a visitor is coming, he just picks up first two letters, if they exist in his list or not. And if it exists, that means he may be in the registers, or in case there is these two letters do not exist in his list, he can confidently say that this user does not exist in actual list. Okay, now going back, let me give a concrete example. Let's say there was Sandeep, there was Vaibhav, Let me pick few more names. Kiran and Matthew. Okay. So who else? All right. And let's say there were, just for the argument's sake, Sanjeev and Mark. So this is the list with the Watchman one, full big list. Okay. Now Watchman zero would get only the first list of only the first two characters. So it'll be SA, VA, KI, MA, SA, and MA. Now you can see that SA and MA has come twice. So when we do a sort and unique, then we have these these only four entries. Okay. Even if there are a million entries here, a billion entries here, the entries in second one can go up to only 676. All right. Now, let's say a visitor comes with a name. A visitor with the name, let's say Bill comes in to Watchman Zero. So what will Watchman Zero will say? Anyone? Yes or no? If Bill comes to Watchman Zero, what will Watchman say? He'll say no. Correct? Thank you, Matthew. Good. Because BI does not exist in Watchman Zero's list. Okay. So Watchman Zero has been given a trimmed down version of the full list. Okay. Basically first two characters of each word and deduplicated. So he says no, that he doesn't exist. So nothing happens further. Bill is rejected. Bill does not go forward. Now, in case Sandeep comes here to Watchman Zero. Watchman Zero checks and says yes. And then the request goes to Watchman 1. Then the next step is to go to Watchman 1. Okay, this is the next step. So in the next step, we go to Watchman 1 and Watchman 1 checks whether that word exists or not. Okay, in the real register, and he says yes. Okay. Now there could be another possibility that, let's say, what should I say do here? Let's say Sankalp comes into. Let's say Sankalp comes in. Okay. Sankalp, the first check happens at Watchman Zero. What will Watchman Zero say? Anyone? Yes or no? Good. So Watchman Zero says yes, correct? And then the request goes to Watchman 1. And Watchman 1 says no. So at this point, you can see that there is a overkill at some point where for Sankalp and Sandeep, there are Watchman 0 and Watchman 1, both are busy. Okay. So these strategies are very good when the requests which are coming in are mostly something which does not exist in our database. If most of the requests lie in this particular bucket where Watchman Zero itself keep rejecting, then our Bloom filter will really work. And that's the case with mostly with HBase, that most of the row ID lookups, whenever we are doing a row ID lookup, there is a lot of times that row ID keeps missing. Okay, so Kiran, now you can think about it. when we were talking about row ID lookups, it looks like it will be very expensive, but HBase has solved it by having these kind of strategies. The only difference between HBase strategy and this example is the way we are generating this list for the Watchman 0. Okay, right now we have just done a very rudimentary one where we have picked up the first two characters of the row ID. Instead, in the real, in a practical examples, what you generally do is you compute hash code. You compute hash code, and hash code becomes the list for the Watchman 0. And this Watchman 0 is called Bloom filter. This is called Bloom filter. So Bloom filter is a strategy which makes it possible to reduce the load of the searcher by creating the trimmed down version of the main list, main row IDs. And this trimmed down version of main row IDs is heavily efficient in the sense that most of the, if the request which is coming from user, if it doesn't, that particular row ID does not exist, the Bloom filter should be able to quickly tell that. Right? Is Bloom filter clear to everyone? So Bloom filter basically filters these kind of requests. Do you have key 1? If it is no, then it's no. If it is yes, then it may be or may not be in the actual storage. So Leonid's question is, do traditional databases have something similar to Bloom filter? I don't think so. I've not seen it, but so in one of the situations when I had to do the same thing, and when we were doing a lot of real time processing and we had to quickly reject things, what we did was, even though our data was in MySQL, what we did was build a server with a huge memory on which we installed Bloom filter. Okay, this there is a library in Java as well as Python to emulate Bloom filter strategies. Okay, that also brings us back to the point, the way we keep on in the way we used to update the index whenever there is insert happens. In the same way we upgrade the Bloom filter also every time we are inserting a record, and we basically update the Bloom filter also. All right. Now there is a question. Let me try to understand. So Leonid is saying, wouldn't something like calculate field serve that purpose? Calculate field, as in you mean to say hash code to generate the list? Oh, calculated field. You mean the automatically generated fields in databases? Um, yeah, but right. So most of the databases, say, let's say you have created an index on a field which is a calculated one, it might serve the purpose. But again, for every request you are hitting the database. Okay. But when you have, okay, when you can afford to hit the database for, so let me explain what I have understood. So what is Leonid suggesting, that if you have a database table and you add one more field called calculated field, and you create an index on that calculated field, and this calculated field is say hash code of some value. So can't it serve the purpose of Bloom filter? Yes, it can partially. Okay, but again, when you are doing a processing, when a request processing is being done, you have millions of records in this database. Even this index lookup is going to be slower for your purposes. Okay, so it makes sense to have a central server which has caching enabled, or which has this mm, Bloom filter installed. Bloom filter, there are libraries to emulate Bloom filter also, and you serve the data from the Bloom, check the data in the Bloom filter. If it is not, then you reject it on the main server itself and don't have to make a trip till the database. Okay, all right. Good, good. This is a good discussion. And yeah, all right. Now, Weber's question is that Weber's point is that one in storage and one in Bloom filter, just like indexing. Yes, kind of indexing. But in case of indexing, the difference was if we found something in index, okay, if index says that yes, this person exists in our phone directory, he exists. Okay, but in case of our Bloom filter, that's not the case. Make sense? That's the only difference, although it behaves like an index. Weber was able to understand what you're trying to point. All right, great. Next is that if you are inclined towards Java programming and you want to build some product which is running on HBase and which also has many other features like coprocessors. Okay, let's say you are trying to implement a security model where you do not want certain users to access the data, or you want to validate the data before it's getting inserted into database. In those cases, you can implement coprocessors. Coprocessors parallel in the RDBMS world is called triggers. Whenever something happens, you can handle that using a trigger. Okay, so a coprocessor basically provide gives you the ability to to handle the incoming requests, and as well as handle the handle the get and post, or put and delete. Okay, so pre-get, post-get, pre-put, post-put, pre-delete, post-delete, those are the kind of functions you can override. Okay, to do that you just create a class, whatever class name you gives here, and then say extend base region observer coprocessor. Okay, and then whichever method you override, you can hook, you can place your hook. Okay, you can say that pre-get is this. Now in pre-get you can either throw an exception saying access is denied, you are not allowed to access the value, or do nothing, meaning return whatever is the input value. Okay, so that way you can either do security access checks, you can also do data validation, and there are many other use cases that you can do using code processors. And once you have created this class, you can put it in XML file which is available at this location called hbase-site.xml, or you could put it in the You can put it in a attribute in the table. Okay, you can put it in the attribute in a table, like have a table description, and then you can put the value of this class name and keep this in the in a location from where HBase will pick. All right. Next is to access the HBase service. You can use the REST interface like this. Okay. So, but before that, you'll have to start the REST API. So, in case those who are not aware about the URL scheme, REST is basically accessing data over the URL, and URL is generally defined like this, starting with a scheme: HTTP, HTTPS, FTP, and Chrome and whatnot, and then login colon password, followed by at, and then your actual website name, then followed by port number. If you do not specify port number is taken default based on the scheme. Let's say if for HTTP you did not mention the port number, that means it will be assumed as 80. If you are using SSH or HTTPS here in case of scheme, the port number, and you have not specified a port number, the port number will be assumed as 443. So this port number, if you do not provide, it is guessed based on the scheme. After this, there is a path to the file name, and then parameters, or you can tell them queries, parameters, queries, and then you have the fragment. Fragment does not reach the server. It is only for the client. So this fragment after hash always remains in the browser or the client side. It doesn't reach the server. Okay. So this is the standard syntax of REST call. So we can start our REST service. So we can start the REST service. All right. And then start accessing the data using the URL. Okay. Sorry, not Hadoop one, because we have started on Hadoop too. So let's see what it says. It says table does not exist, which is correct. We can see it was call one, row one, CF1, or my CF1. What was that? My CF1. Yeah. So you can see that it has downloaded the data. 1, 2, 3, 4 is what we had written. Good. So it's very useful. You can basically use this URL in the JavaScript and access the data and start working on that. All right. In the similar fashion, you can call the put also. Calling the put from the browser is little difficult. All right. Next is that in case you are inclined to use a JDBC kind of driver, please have a look at Apache Phoenix, which is good JDBC connector. All right. So and that's pretty much for this session. So we can we can proceed with the session number 8 on Spark after the break. Right? Let's take a break of 10 minutes. All right, so can we start now? Great. All right, so everybody in? Should we start now? I only got a confirmation from Matthew. Great. All right, so moving ahead. So we talked about HBase, which provided us a kind of humongous storage on top of HDFS. Now, actually, before even we had talked about HDFS or anything, we should have talked about something called Zookeeper. Zookeeper is a database kind of mechanism, or you can call it a file system, which can help us in coordinating. Okay, and what does it mean by coordinating? Let's try to understand that part. Imagine that there is a big inbox where lots of emails are coming, and you need to process these emails. What could be the good strategies? Anyone? How would you process these emails? By using multiple machines. I'm not calling using it multi-threaded. There are multiple email processor servers which basically connect to the inbox, read the email, and process them. But if you think about it, if there are multiple such processors, all of those processors will end up reading the exact same email. Now, how could you avoid that? How could you make sure that one email processor does not process the emails which has already been processed? Anyone? Matthew says index. Okay. Index as in uh, keep going. Come. So the question here is there is a big inbox which need to be processed by multiple email processors. These all email processors have exactly identical code. They all have the same source code. We have installed our email processors on 3 4 machines, multiple machines, and all of that email processors is talking to the same inbox. So the question is how can this function without one email being processed by multiple email processors? All right. Anybody else? Matthew says index by date and send date and ranges to multiple machines. Okay. So few things. One is you have no control over, you have no write permissions. You cannot even mark one email as read or unread in the inbox. Second, there is an ID, there is an identifier for each email. Okay. Anybody else? Okay. So Weber is suggesting that a response needs to be sent back that processor one has accessed inbox. Good, good. But the problem is that we cannot write to this inbox. We cannot mark an email as read or flag it that is being processed. Yeah, Matthew, Vaibhav, Kiran, Deepak, Leonid, John. It's sorted by date and time, so it's not written anything. Okay, but these email processors need to also communicate with each other, right? In your case, Matthew, that I'm going to take care of from this time to this time, this date to this date, right? Okay, okay, correct. So, okay, so basically, the same thing is Weber also saying that we take the processor one need to inform the processor two and so on, but that becomes quite confusing. Why? So one of the suggestions which we have is that we have some kind of a third database, okay, some kind of third system in which email processors can mark that I have processed this particular email ID or I'm processing this particular email ID. And email ID as in ID of the email. There's a unique identifier for each email. Okay, so you have this central database in which all the email processors can write as well as read from. Make sense, Matthew and Weber? Because if you try to communicate amongst each other, then this first one has to communicate with both, and then second one has to communicate with all. So there will be total number of six conversations, which will be too difficult to manage. Okay. So this is called coordination. We are trying to coordinate amongst these email processors by the way of using a third system. And this third system is generally the zookeeper. Okay, this third system is generally the zookeeper. And there are many more use cases when we go ahead. Even situations like switching between primary and secondary. In case of name node, if there are two name node, one is primary and secondary, and if there is a coordinator between the two, then switching between them can be very, very simple. Similarly, in case of HBase, we had region servers. We can keep on adding more and more region servers, and some of these region servers might keep shutting down all the time, right? In those cases,
The HBase master needs to know that which HBase region servers are available and which are dead. So that's another example of coordination. Okay. So when we talk about coordination, coordination is of various forms. And and Zookeeper is probably the de facto standard of coordination. Even if you have a million clients trying to coordinate with 100 servers, or you have, say, 100 users trying to coordinate with 100 services, in all those circumstances, Zookeeper works really great. Zookeeper works really great. So the role of this database is being played by Zookeeper. Now, question always remains whenever we discuss all this. Question always remains that that will our database able to handle it, or do we require MySQL? Okay, if you have huge coordination, then normal database cannot really handle, and generally it's an overkill. All right, you will see a lot of things when we talk about Zookeeper. So a Zookeeper is basically a distributed coordinated service, meaning Zookeeper itself runs on multiple machines to provide you a high availability of coordinating service. Okay, it exposes a simple set of primitives. It's very easy to program to, and uses a data model directory like a directory tree. It's not really like a database which has table and rows. No, it has a folder kind of a structure. So you can use it for synchronization and configuration maintenance. Okay, this coordinating service, this server on which all the threads will write, all the machines will write the data, does not suffer from race conditions or deadlocks. Can anybody tell what is a race condition? Anyone? Inconsistency. So Matthew says inconsistency. Anybody else? Hmm. So what exactly is race condition? Whenever two programs try to compete with each other to get certain resources, then we call that race condition. That two programs are competing with each other, and they might end up corrupting the data or doing some illegal operation when they are competing. For example, imagine that there were two ATMs in a same room. There is a ATM room in which there are two side by side ATM. So what you thought of doing a little clever things. You went into the ATM room and logged in into both the ATMs using your card. You inserted your card, took it out, and then um, you took it out from another. Now let's say you try to withdraw the cash from both the ATMs at the same time. Okay, if these ATMs suffer from race conditions, there are chances that they end up withdrawing cash twice but deducting only once. So
when you have these kind of circumstances, when there are two programs trying to modify the same variable, and sometimes they might corrupt the data. So that's called a race condition. A deadlock is when two resources are dependent, waiting for each other. When two programs are waiting for each other, then we call it a deadlock. Okay. So any coordinating service, whether it's database, whether it's zookeeper, whether it's a file system, should not suffer from race conditions or deadlocks, but they do. Okay. In case of zookeeper, the main reason why people started using zookeeper is that it is really great at coordination. It does not have race conditions or deadlocks. The design goal was simple. It's a hierarchical namespace. It has got something called Z nodes, which are equal to the files and folders. And most of the data, I mean all of the data is actually available in the memory. So it has got a high throughput and very low latency. Latency is time taken to serve the request, and high performance is used in large distributed environments, as in, because it's the service itself, zookeeper itself is distributed, so it is used in by millions of servers at the same time. So it's strictly ordered, as in there's a synchronizing construct in this. All right. Next is the replicated part. Okay. So this zookeeper is not a single machine. It is a bunch of machines connected together, and these bunch of machines are serving as zookeeper. The client, the user, keeps a TCP connection to each of these zookeeper machines, and these zookeeper machines keep on sending the watch events. Also, the the zookeeper expects the user to keep sending the heartbeat, otherwise zookeeper will expire their service. Okay. In case there is a problem in the network, the client automatically connects to the server. So this magic of sending heartbeat from a connection, from client sending heartbeats, as well as automatically reconnecting to another machine, is a part of client library provided by zookeeper. Okay. So these servers which are together are called ensemble. We'll talk about it again. So these all servers, they know each other, keep all of the data in memory, and transaction logs and snapshots are persistent. Okay. So one of the design goals is to be very fast, and for small data. That is why the decision like keep the data in memory have been taken. It's not great for storing bigger data. So it's great for only coordination where you have small information about logs, information about numbers, that's all. So it's replicated and highly available. Third is ordered. Zookeeper stamps every request that is coming in with a number. That means it can always resolve the conflicts, that which one came first, came second, and so on. And based on that, it can clean up the transaction, it can handle the race conditions, as well as it avoids the deadlocks. Okay. Fourth is it's really fast. It because most of the data is in memory, therefore it's really fast when you have to read a lot in a ratio of 10 to 1, as in you are reading 10 times and writing once. In all these cases it's really highly performant. So 10,000 operation per second was the performance which have been computed at Yahoo. All right. To check quickly if a zookeeper is running or not, you can simply connect to the 2181 port and say hello. Okay? You can say things like, can say. All right. So you can see that we are saying, "Are you okay?" Echo to this particular port, and it's returning that I am okay. So these are some four letter commands for checking the status and doing the basics of diagnostics on on Zookeeper. Right? Is this clear to everyone? Okay. You can install Zookeeper directly from downloading from there, and then you can start Zookeeper. And right now we are going to start the Zookeeper client. So this is Zookeeper client, and this is what was that? All right. So we can simply say that there was a way to check the status. Never mind. All right, we'll show you that. All right. Next is the data model. This is something very important. No, no, race condition. RAC, race condition, not risk condition. I was talking about this race conditions. Okay. All right. So the data model to store data in case of Zookeeper is a hierarchical file system. Is like a hierarchical file system. Or if you are from computer science background, then it's exactly like a tree in the data structures class. Okay, so it has got nodes. Every node stores some data. Every node stores some data, as well as every node can be the parent of some other node. All right. Okay, so you can think of it like a file system which is highly available, and HA means highly available, and it has it has got this hierarchical system where this is one node, this is one node, this is one node, this is one node, and so on. And you can write data to every node and read data from every node. So every node is persistent, as in it. I mean, if you deleted it, it will get deleted. If you otherwise, it will remain there. Persistent, as in, all right. Okay, so Z node is the way to store data, and that's the minimum unit of storing data. As in, you can either update a Z node, I mean, replace the full text. You cannot append to a Z node. Okay, so Z node is the minimum unit of segregation between things, and there are three kinds of Z node. First one is persistent, which is the normal one. If you simply create a Z node, it will that's called persistent. Second is ephemeral node. This is something different. This means that such kind of nodes called ephemeral nodes, such kind of nodes disappear. Such kind of nodes disappear if if the person who created this node disconnects. Okay, this is like a temporary file which gets deleted every time the user disconnects the session, and that so ephemeral nodes are very much required for coordination. Okay, so these gets deleted in around 5 seconds if the user is not responding for 5 seconds. That's why the client key has to keep on informing the server that I am alive, I am alive. Otherwise, all the ephemeral nodes created by this client will get deleted by Zookeeper. Okay? Ephemeral nodes cannot have children, and though they are tied to the session but visible to everyone. Tied to the session means as soon as the session expires, these nodes disappear. So here we can create a node. Let's say we are saying create and we call it July 11. Okay, with some data. Okay, so it's created. Now we can get the details about this node. Okay, you see there is some data already stored on this node. All right. So we created a we created a node, and we, if you want to see what all nodes are there, these are the nodes under slash is also a Z node, which is at the top level. So you can always say get slash, and it'll give you the data. So this, it has only blank, there is nothing in it. So we can say ls this, and you have these nodes. All right. Okay. So you can see there are so many other nodes. You can create another node under slash 11. Here also you can create some other node and put some information. Let's say I'm putting my name. So you can see under slash you will see 11 July, and under 11 July you will see, oh, you are there already. Already some other nodes are there. Okay. So okay. So we can say create 25 July. It was already there. Okay. So yeah. Now there is something called ephemeral nodes. Ephemeral node disappear if you disconnect. So you can create ephemeral node by saying create minus e, and you can say slash 25 July. Okay. So there is this stupid bug in this. So we can say create minus e slash 25 July, and we put some data, ephemeral node. Okay. And if you disconnect at this point and connect after some time, then you can see that right now it's created, but after some time it will disappear. Okay, why? Because I've disconnected that session and created another session. It'll take few seconds. All right. The third kind of Z nodes are sequential node. These are the Z nodes which whose name is auto generated. okay, with whose name is auto generated by basically you provide a prefix and the full name of the node is auto generated. Okay, and how is it auto generated? Basically, a number is suffixed on the prefix which is given by you. Whatever string you have provided, a number is attached to it, and this number gets generated every time you create a node. So this number is different for different parents. Every z node when it's created, every sequential z node when it's created takes this counter from their parent node. Okay, so let's create a, let's create a let's create a parent node. Okay, now you can see that 25 July has disappeared. Let's create another node called parent. Okay, let's create a parent node. Create a node called um, parent. Okay, or parent one, and we put some string. So we created this node, and under this node, let's say we want to create a sequential node. Okay, so we provide a prefix, and automatically this is a text which we are this is just data which we want to push here. You can see that automatically a number has been generated, and every time we run it we get a different number. See that? So in parent 1 these are the numbers being created. Okay, so starting from 0 0 it is going to 1 2 3 and so on. And if you try to create instead of this, if you try to create under one of the children node, then it again starts from 0. It doesn't start from 4. Okay, so every parent node counter is reset to 0, is set to 0 when we start creating the z nodes. Make sense to you? No? So these are sequential node. And where do you use such kind of nodes? You must have seen the ticketing systems where a number is automatically generated. If you have a distributed systems where there are multiple machines who are supposed to log the tickets, every one of those need to create an ID every time, and there could be a conflict amongst them. Therefore, in all those scenarios, the sequential node matters a lot. You could utilize sequential node in generating the IDs. All right, all right, Kiran. So So you were asking about generation of the IDs. This could be quite useful to you. All right. In case of HBase, we wanted to generate the unique row IDs. Maybe you can utilize a coordinator service from a sequential jet node. Yeah. So are you guys with me, or I'm completely disconnected? So a zookeeper provides you a way to store small data for the coordination. Now Matthew's question is, what is the purpose of this? I think if you want, I can focus a little bit more on this. So, whenever there is a coordination requirement between multiple machines, okay, between as I showed you that there are email processors we were writing, there might be a team where which is working on say crawlers. There are multiple crawlers running on multiple machines. They require coordination. In olden days, we were very happy because we had this nice thing called thread. We could place lock on thread, and so that one node, if doing something, will not let any other do the same thing, right? But since the day we have started with distributed computing, what has started happening is coordinating between multiple servers have become really, really difficult. Either all of them they built the constructs for coordination, or they can they can use a service like Zookeeper. Okay, so we have all right. Okay, now let me try to answer your question. These are very valid questions, and we should have asked these questions. Okay, let's try to answer these questions. These are very valuable questions, brilliant questions actually. So Webber says that if I access my Gmail from laptop and then my mobile, an email already accessed from laptop will show as read. Is this in line with Zookeeper or similar system? Yeah. So for this kind of coordination, although you have email server which provide these functionalities, so for this, the email server itself will suffice. Okay. But in some cases, when this coordination gets difficult, you might have to have a Zookeeper kind of service. Okay. Yeah, you are right. It's written in the inbox. But in case inbox is not letting you write anything and there is this new tool which you are writing, in those cases you could use a service like Zookeeper. Now coming back to Matthew's question, then what is so special about Zookeeper? Yeah, sounds like we can do most of the coordination using MySQL. And the follow-up question is, what is so special about Zookeeper? It's as simple as that. So first, Zookeeper runs in a heavy, high availability mode, as in case. So Zookeeper is not a single machine, although it sounds like it must be a single node which is trying to provide a coordination, because every like a traffic light, everybody when they have to cross the traffic, they have to look at the traffic light. In the similar manner, Zookeeper is utilized by many services. As of now, Zookeeper is used by HBase. Let me show you. So let's ls. You can see here. Okay, I'll show you. App 20. There is something called servers. Not server. Yeah, HBase unsecure. Do you see HBase unsecure? So HBase and its members are coordinating from here. Let's say ls HBase unsecure. You can see that there are all this information shared across all these machines. So I'll show you rs is there. So rs, it is showing that these are the region servers which are up right now. 2, 3, and 4. Is that so? I think this example should set your expectations, right? You know what's happening here? Let's try to see what's happening. This is okay. This is also okay. Now let me go to HBase. Yeah. So here it's showing that there are three region servers. One is 2, other is 3, and other is 4. Okay. And let's have a look at it. So 2, 3, and 4. All right. So the way this coordination is happening is all these region servers do not know about their master. They do not know about their HBase master. Instead, they know about region server. So as soon as these region servers are coming up, they are turning on, they are connecting to the region servers. As soon as region servers are coming up, they will connect to our zookeeper and inform zookeeper that I am up. How they inform? By creating a temporary node by their name. This is their temporary node. This is their temporary node. They have created their temporary node into under this, under rs they have created an ephemeral node, so that in case Hadoop 2 goes down, this node will automatically disappear, and thus providing a coordination between HBase master and HBase region server. HBase master will come to zookeeper and ask, hey, do you know who all region servers have reported to you? And zookeeper will tell happily that these are the three nodes which are under this. Okay. Now coming back to what is so special about this. So special about this is it is highly available. Even if few nodes go down, it will still remain up and running. Second, everything is memory and therefore really fast. Third, it provides constructs such as ephemeral nodes, and logs, and it does not suffer from any of the racing condition or deadlocks, so that the coordination is really possible. That's why, starting with hdfs uses zookeeper to coordinate between primary and secondary. Similarly, the primary secondary name node, similarly between the name node and the data node, everything can be configured to use zookeeper to provide high availability in case of uh, name node. Okay, so in case a name node goes down, automatically zookeeper is informed because of ephemeral node. The ephemeral node will disappear as soon as connection goes down, and therefore we would know that the primary node has gone and the secondary node takes its place. So that is how zookeeper is special. Also, zookeeper is not a single machine, it's a ensemble, it's a group of computers which provide you this high availability. Now question will ask, you might ask that what is bad about it, why not? Okay, a simple answer is that it can only store it can only store small data, not big data, only for small data. Why? Because data is in RAM, all of the data, although it's supported on the disk, but it's also in the RAM. Second, data is replicated n number of times. Replicated n number of times, where n is equal to number of nodes. Okay. Can we interact Zookeeper with Zookeeper through Ambari? Y- Yes, so let me show you. So here, all right. But you cannot interact it with through Hue. All right. So we talked about the general use case and the sequential node. Now, are you convinced, Matthew? Did I make a point? Second question from Matthew was, does Zookeeper run automatically, or do we need to always go through this and set it? So right now Zookeeper was already running. We just had to connect to the client. All right, great. So basically, understanding the use case is very important. So when you have a small data but huge coordination need, you go for Zookeeper. Zookeeper does not depend on any other system. HBase depends on HDFS and so on, but Zookeeper does not depend on any other tool. Okay, it can run at its own. That is why it's being used by HBase. It is used by uh, lots of other services for coordination. Okay. All right. So there are various kinds of operations which Zookeeper provides. We have already tested the create command. There is a delete command. There is a ls command, we ls or exist command, and get ACL or set ACL. What is ACL? Access control list. Since we are talking about a central service just like database, it is of course required to provide an authentication layer. Okay, so that's what Zookeeper provides you. Okay. Next is, you can get the children, you can get the data, or you can synchronize the client's view from Zookeeper. Okay. Now, when it comes to the transactions, Zookeeper provides you the complete form of transaction called multi, or you can say that whatever changes you want to make to Zookeeper, you can chain them in a single transaction and get it done in a single shot, rather than rather than doing it individually. Okay, so either all of the things will get done or nothing will get done. There, nobody will observe the intermediary state. So that's the status of transactions under Zookeeper. Next is the APIs. Although we have been using the command line, but Zookeeper provides you two kinds of APIs. One is called asynchronous, other is called synchronous. Can anybody tell me the difference, please? What is the difference between asynchronous calls and synchronous calls? Yeah? Sync and async call, anybody? Leonid says sync will wait for the completion, brilliant, while async will not, but rather use a callback, brilliant. Thank you, Leonid. Alright, so when we are dealing with lot of concurrency or a really high optimization, we do a lot of things starting from the threads to async calls. Okay, that is why Zookeeper's library provides async at sync methods. Same method is available in sync, as well as same method is available as asynchronous. And what is sync and async? In case of sync, when I say When I'm making a call to normal function, it's called synchronous call. I'm waiting for the I'm waiting for the function to return me the value. I'll keep on waiting, and I will not do anything else, right? I'll keep on waiting for synchronous call to return. For example, here you can see the exist. But in case of a synchronous call, I will, instead of waiting, I'll say execute this function. Once done, call my callback. Okay, that's async method. You can see here in exist, we are saying that check if this path exists, and once done, inform my callback. Don't, but let me do other work right now. Okay, so these are two kinds of APIs provided by Zookeeper. Okay, the core APIs of Zookeeper client are in Java and C. Rest of the APIs are wrapper over those components. So Leonid is saying, if Zookeeper is so fast, why would one use asynchronous call? Okay, so if you are writing is slower. Not Writing is slower because writing happens. You will see that. So you would like to do lots of things in async manner. Okay, so there are few functions that might take few more time, and even if these things take few milliseconds, in case of optimization you don't even want to waste that time. All right, then there is another important construct provided by Zookeeper to us, which is called watches. So the client keeps on getting notifications when something happens on the Z node. Whether Z node gets deleted, it's got more children, the children got deleted, and so on. The watches are triggered only once you have to re-register a watch. And how do you register a watch? By calling a function like exist, get data, get children. Okay, you by while calling these functions, you can mark that inform me of any changes of this kind. Okay, then the watch of exist gets triggered when the node gets deleted or created or its data get updated, and the watches of get data are triggered when node is deleted or has its data updated. Get children are triggered. The watches of get children are triggered because when the Z node is deleted or it's any of the child is created or deleted. Alright. Now the access control list is made up of two things. One is authentication and authorization. Who can tell me the difference between authentication and authorization? Okay, we have a good question from Vaibhav. Correct. So Leonid says that authentication means login and authorization means access to the resources. That's correct. So access control list depends on few things. One is authentication. Authentication can be of three types. One is based on login password, which is called digest. Other is Kerberos, and other is IP based. Okay. Now access control list is a combination of authentication, identity for that scheme, and then authorization, which is permissioning. All right. Good. Good. Now coming back to the question, does developer need to worry about setting up Zookeeper? No, but developer need to know. But developer needs to know the basics. Okay. All right. Now there is something interesting which you guys will really appreciate, because this is something which is common to lots of other highly available systems. Let's discuss the architecture. It's not that complex, but you will find it really interesting. Okay. So the Zookeeper runs in two modes. One is called standalone, which is only for testing and it is runs only on one machine. Other is replicated. In case of replicated, Zookeeper runs on a cluster of nodes, on many number of nodes. Okay, and this cluster of nodes is called ensemble. Ensemble ensemble contains lot of Zookeeper node which keep running and serving to the customers. Also, the Zookeeper's architecture is little different. It tolerates as long as there is a majority of nodes up. Out of 100 nodes, if more than 50 are up, then Zookeeper is okay. Alright. Now, when you have Zookeeper's machines, you have like 10, 15 machines connected, or maybe 100 machines connected. What exactly happens? The first thing that happens is called leader selection. This ensemble selects its leader by itself. If you remember the way earlier, name node was elected by us, name node was selected by us. We said that okay, this name node looks good, let's make it a name node, and we hardwired it. But in case of Zookeeper, the leader selection is automatic. Okay, and the way it happens is all the machines in the ensemble, they vote for each other, and they vote for each other, and whosoever wins the voting becomes the leader. And what is the role of a leader? All the readers, and whenever you want to read the data, you go to the followers. When you want to write the data, then you go to the leader. Leader is for writing data, and followers are for reading the data. Okay. Now, okay, so as soon as somebody becomes leader, everyone synchronizes their state with the leader, and if the leader fails for any reason, the re-election happens after around 200 milliseconds. All right, all the write requests are forwarded to the leader. Okay, and leader broadcasts the updates to the follower, because all the followers need to get the same update which leader has got from the user. So all the followers pick up the data from the leader. Now, as soon as when Zookeeper is trying to write some data, and the user has written the data, as soon as Zookeeper is able to persist it in the majority of the disks, then then a confirmation is sent to the user that the data has been written, data has been saved. Okay, any questions at this? No. Okay, also the way writing happens is really persistent, as in the data gets written first to the disk, then to the memory. Okay, this diagram will make it further clear. So there is an ensemble, there are these three machines which are part of the ensemble, and one of them is marked as follower, and two are, one of them is marked as leader, while rest of them are followers. So this is a leader. All the people who are trying to write the data, they will always go to the leader, while those who are reading, they can read from anywhere. All right, is everybody with me? So here there is one more important aspect is, in case more than 50% people are not available for voting, there will be no leader. In case there is already a leader, and and it has realized that only 50% more, less than 50%, less than or equal to 50% are available right now, the leader will quickly step down. The moment leader realizes that only half of the candidates are here, half of the candidates are only pinging, that means there's something wrong, and at that very time the leader steps down. Okay, so Matthew's question is, how do they conduct election? The way elections are conducted is, all these nodes, this will give the votes to all the people including itself, this will give the votes, this will give the votes, and these votes are dependent on the rate at which nodes are responding. So its vote will be for, will count how much time that did it take to ping leader, how much time did it take to ping this node, and so on. Based on that, they form the opinion and they form the voting. Whosoever wins the election becomes the leader. But if if leader did not get majority, there will be no leader. Okay? Leader will quickly step down if it realizes that there is the moment it realizes that the leader has lost the majority, it will quickly step down. Okay? Now, can you guess why does it require majority? Doesn't it look strange that we have, let's say, we have 20 machines, okay? 10 are dead, 10 are alive, 10 are alive, still no election, no election, okay? Don't you find it strange? Don't you find that your 10 machines which are still alive are not being utilized at all? Why would it require majority? Can anybody guess? Why would an election require majority? Okay, so let's have a look at the elections. If you have three nodes, A, B, and C, A as a leader and A dies, okay, what will happen? Will someone become leader? Question to all of you. In this case, will someone become the leader? No? If you have, so I was saying that leader can be elected only if majority of the nodes are up. Okay, majority means more than 50%. So, and what does it mean by majority? Two out of three is a majority or minority. Is two greater than 50%? Answer is yes. Two is greater than 50%. All right. Matthew's question is, one will get two votes and other will get one. These votes are not in terms of one and one. These votes are also carry a weight, as in how responsive is the server. All right. Good. Good. So there will be no election. sorry, as soon as leader dies, two are left out of three, which is majority. Therefore, they will elect any of the node. They will elect either B or C as the leader. Okay, so if A dies, quickly B or C will be elected as the leader. All right, sounds straightforward. Now, what happens in case B also dies? A already dead, so we elected C as the leader. What happens in case B also dies? Anyone? Alright, this is interesting. So C will step down. Will C will not remain the leader. C will step down because out of three, right now only one node is available. Therefore, therefore there is something seriously wrong. So C will step down. Okay, as opposed to the common sense, C will actually step down. C will not tolerate the lack of majority. Can anybody guess why? Do you find it strange? So Matthew says that he's a bad leader. Not really. He's a good leader. He's stepping down. Just that the situation circumstances are bad. Hmm. Leonid has a point. I will take this as a good point. Seems like elections are compromised. Could be the case, yes. Yeah, sort of impeachment has happened. That is Matthew's point. Good, good. So basically, whenever at any point of time, leader is not does not if the leader does not have majority, he cannot remain leader. And this comes from a strategy called Paxos strategy, PAXOS strategy. Strategy for because all these nodes are identical. They have all the same software. Even while installing the software, you did not differentiate between leader or follower. Anybody could become leader, anybody could become follower based on the votings, right? So, all right. So, does anybody know why? Why is a majority required? What is it? Will our data get corrupted? Will something else wrong happens if the majority rule is not followed? Okay, let me try to answer it. Imagine that you had two data centers, data center 1, data center 2. An ensemble of 6 nodes, 3 nodes in one data center, 3 nodes in another data center. Now imagine what happened was the network got partitioned. This is called partitioning of network. Basically, the network connection between the two data center is down. Okay, the cord has been disconnected. Now, now what will happen? A was the leader of data center 1. A from data center 1 was the leader for the whole ensemble from A to F. Now, will A remain leader or what exactly would happen? If majority rule was not followed, what exactly would happen? Everybody starts re-electing. So E, F, D also start participating in election while A, B and C again re-evaluate the election. In case the majority rule is not followed, the rule that A leader can become leader only if there is a majority. If that rule is not followed, you know what will happen? Both data center 1 and data center 2, both data centers will have their separate leaders. Okay, and both of these leaders will start accepting the write request, accepting the change request, all the put, delete, and everything. A and D both will start accepting. Now imagine what happens if the same data set being modified by two different parties at two different times. Then you've gone for a toss, right? So in A we created a record, and in D we tried to delete the record, but the changes done at A never reached D. Therefore it will become a chaos. The moment there are two leaders, it's a chaos. In case of zookeeper, same is true for exactly same thing is true for MongoDB also. Make sense to you? Now do you understand why do we require majority votes? No? So no, A will step down. A will step down. Ideally A will step down because 3 is not majority out of 6. 4 is majority out of 6. 3 is 50%. So if we have this rule that for an election to be successful, there has to be more than 50% people, then there cannot be any partition of the network which can be bigger than this partition. There can be only one such partition in a network which has got more than 50% of node. There cannot be any other partition. There can be only one partition of the network which has more than 50% of nodes. Okay, does it make sense? It's like saying bigger than half of the cake. If you are if you have to ensure that you get the biggest piece of the cake, ask for more than half. If you ask for more than half, you will always get the biggest piece because that's the only one piece possible. Therefore, there cannot be two leaders if we follow the rule of majority, because there can be only one such partition of the network which has more number of nodes than 50%. Does it make sense, Matthew, Vaibhav, Leonid, Kiran, John, Deepak? This is very important. I have seen lots of people, they don't, I mean, it took me a lot of time to just figure this out. Why is there a rule of majority? It took me some time to figure this out. Okay. And why am I emphasizing on this? Because it's a standard algorithm. There are multiple tools, not only Zookeeper, but also MongoDB and others also follow the same principle. All right. Okay, then we can continue discussion from on the next session. And if you have any question, feel free to drop me an email. All right. Bye bye. Have a great day ahead. We'll start from the slide number 30, 33. All right. Bye bye. Have a great day ahead. Thank you, Leonid. Thank you, Matthew. Thank you, Kiran. Thank you, John. Thank you, Deepak.